This is the first video for 2.2 part 2. Last time we talked about graphing quadratics and using their axis of symmetry and identifying the vertex. So you should now be able to put a quadratic on a graph and then state its vertex and its axis of symmetry. Today we're going to talk about its max or min value. So that is the highest point, the highest point y goes to, which is the y value of the vertex if it opens down. That's when it has a maximum. Okay, so it'd be opened down. So that means when a is negative. So when you have that reflection piece in there. And then when it's positive, there's no reflection, so it's going to open up, and the vertex, the y value of the vertex will be the minimum. All right, so down here kind of explains a little bit more. So when you find your x value, and you plug it in and you find the y value, if y, oh, that's not what I wanted to circle, I'm sorry. If a is greater than 0, you know it's opening up, and you have a minimum, a bottom to your parabola. And then you same thing with having a top. And we're also going to talk about the domain and range. Well, when we talked about domain and range of our parent functions in the chapter 1, we went over the domain and range of a parabola. It has arrows on both ends, so it is going to go forever to the left and forever to the right, so negative infinity to infinity, or you could say all real numbers. Okay, and that's no matter if it's reflected or not, the range is all real numbers. So far we have not gone over a function that has any other domain besides all real numbers. So you shouldn't get any domain questions wrong at this point. Okay, and then your range, if a is positive, means you're opening up. Okay, your range is the minimum value all the way up to infinity because it's going up forever. So, and you would always put a bracket. So when we write it in interval notation, it's whatever the y value is. I'm just going to put a y of your vertex, and then it will go up to infinity. Okay, or you could just say it's y is greater than or equal to whatever that y value is of your vertex. Okay, and then when it has a minimum, the range is actually going down forever, so it's negative infinity up until that y value of the maximum. Okay, so y would be less than or equal to whatever that y the maximum is. All right, and then we're going to talk about decreasing and increasing. So you're decreasing if you read the graph from left to right. So in this graph right here, if I'm coming in from left to right, I'm going down, I hit the vertex, and then I go up. So if you think of it as like your slope, your decreasing slope is when you're going down. So if I'm headed down going left to right, that's where I'm decreasing. So this would be to the left of that axis of symmetry. So on the left side of it, my graph is decreasing, and if I keep reading it to the right, from left to right, then my graph is going up. So it's increasing on the right side of my axis of symmetry. And then the same thing goes for when you have your a is less than 0, so it's reflected. Reading it from left to right, I'm going up. So these are little arrows I'm doing. Then you hit your vertex, and then you start going down as you read from left to right. So as it goes up, that's increasing. When it goes down, it's decreasing. So it's increasing on the left side of the axis of symmetry and decreasing on the right side. Okay, and we'll get to this part later. So let's go on. We did the first part of number 1 in the notes at the last lesson, okay, before you did that practice. So that was in 2.2 part 1. So we already found the vertex. We've already graphed it. Got our axis of symmetry. Now we need to determine the max or min. So the question is, does it have a max or does it have a min? Well, the y value has a cap to it. It does not cross that, y being 3. So it has a max because it has a top, and that max is 3. Okay, the domain, how far left to how far right? Well, it has the arrows on the end, so it's all real numbers, which is negative infinity to infinity. The range, how far down to how far up? Well, so it goes down forever, so negative infinity, and it goes up to y being 3. All right, and we talk about increasing and decreasing. So on the left side, so the left side of my axis of symmetry, if I'm reading the graph from left to right, it's going up. Then it hits the vertex. So it is increasing on the left of x equals 1, because that's your axis of symmetry. And it's decreasing after it hits that vertex, and then it starts going down. Okay, so this would be to the right of x equals 1. Okay, that's how the book wants you to write your answers. On the ACT and things like that, you'll see the increasing and decreasing as interval notation, just like we wrote domain and range. So, and I wish I didn't draw all those arrows on there, but I did. Sorry. If I wrote this as increasing, well, if I look at how far down, okay, it's coming from the left. Well, it's coming from negative infinity. So it'd be negative infinity, and it goes all the way up to the top when x equals 1. So, because we read it from right to left, okay? So that's why you stop at the y value, or the x value, not the y value. But it doesn't actually equal, it's not increasing at 1, because at 1, it's actually, that's its vertex. So it's really, its line would be not increasing or decreasing, it'd be flat. So we would say a parenthesis. And then after 1, all the way to positive infinity to the right, it is decreasing. So that's how you would write those in interval notation. But for all the purposes of turning this in on big ideas, it just wants you saying left or right of that axis of symmetry. All right, so number 2. So we have it drawn. Now it has a bottom to it right here. So I know that it has a minimum, and it's the y value, so it's 0. And if you look at your vertex, the axis of symmetry is the x value, the max or min is the y value. Okay, your domain, well, it goes forever left and forever right, so negative infinity to infinity, or all real numbers. Its range is the y values. How low does it go? Well, it goes to y being 0, but then it goes up to infinity, so y is greater than or equal to 0. And then increasing, well, that's when it's going from left to right, it's going up. So that would be on the right side. So it's on the right of x equals negative 1. And then it's decreasing, it's going down on the left side of our axis of symmetry. So on the left side of x equals negative 1. All right, let's look at number 3. We have it graphed. I'm glad we wrote out the vertex with those fractions and didn't have to find them all over again. This has a minimum, has a bottom. So I'm going to say it's a minimum, and that is when y is negative 7 over 6, because that was the y value of our vertex. Its domain is all real numbers, negative infinity to infinity. Goes forever left and forever right. But the range, it has a bottom. It doesn't go down forever. It goes down to negative 7 over 6, but goes up to infinity. So it's y is greater than or equal to negative 7 over 6. So if we draw the arrows as we're reading from left to right, it's going that way, and then after the vertex, it goes that way. Increasing is when that arrow is going up, so from left to right. So this would be increasing to the right of the axis of symmetry, which is x equals 1/3, and is decreasing on the left of x equals 1/3. Okay, and remember, if you wanted to write those in interval notation or needed to write them in interval notation, it would be on the left side, it'd be negative infinity to 1/3, and this would be 1/3 to infinity. All right, so now I want you to go to the practice, and this is for part 2, so this 2.2 part 2, and I want you to do numbers 2, 39, 42, and 48. So the first 4 problems. And number 2, I recommend graphing all 4 of those on your graphing calculator and pick which one is not the same as the others.